Yeah, so welcome to the first seminar for the Statewide Biobank Seminar Series for 2025. So my name's Jennifer Byrne, I'm Director of Biobanking in New South Wales Health, and it's a great pleasure to be welcoming Associate Professor Simon Goldstein, who's going to speak to us today about catastrophic risk and AI. Before we get started, I just want to acknowledge that I'm joining you on the land of the Gadigal people of the Eora Nation here in Sydney, and I'd like to pay my respects to Indigenous people in Australia and everywhere, and their many contributions to science and society. So as I said, we have an international speaker today to kick off our seminars for this year, and it is Associate Professor Simon Goldstein, and he's joining us from the University of Hong Kong. So his background is in studying AI, but possibly studying AI from a different perspective that many of us think about in biomedicine, where we're perhaps thinking more about how can we use AI to speed up our daily activities, how can we apply AI or generative AI to write better papers. But Simon spends a lot of time thinking about AI in a much broader context in terms of possible risks to society. And I think it's very important for everybody to be cognizant of the benefits from AI, but also some of the things, some of the risks that will come from this extremely powerful source of analysis that we're all grappling with. So Simon, thank you so much for your time. We're really looking forward to hearing your seminar and look forward to some really interesting discussions afterwards. Thank you.
All right, thank you so much, and it's great to be talking to you guys. I lived in Melbourne for 4 years, so it's good to be back in Australia via Zoom. So today I'm going to kind of give an introduction to the ways of analyzing what are called catastrophic risks from AI. So risks that AI could lead to, the end of humanity or horrible disasters or things like that. So I want to give you guys a sense of what kind of, people who work in AI safety on these kinds of issues are worried about, and, what kind of the argument is that there's a worry like this. And I'll also touch on some specific themes related to, for example, AI deception. So the possibility of having AIs that can deceive humans. So I'll kind of walk you through this argument, and then I hope to have plenty of time for discussion of anything you guys want to talk about, including, for example, if you want to talk a bit about how whether AI will kind of supercharge potential research into biological or chemical weapons is one kind of risk area. So anyways, the way that I kind of think about AI catastrophic risk is to split up the argument into two steps. So what would it take for AI to create catastrophic risk? Well, basically it would be, first, we would have AIs that become extremely powerful. And then the second step of the argument is, if they become extremely powerful, then we get some kind of catastrophic outcome, like AIs destroy humanity. So there's two steps in the argument, and we can think carefully about each of those steps. And so correspondingly, the way I kind of analyze this issue is, well, if we don't have catastrophic outcomes from AI, then there's kind of four different paths that we can take to survive the risk. And basically, two of the paths would be where the first step of the argument fails, so that AIs do not become extremely powerful. And then the other two paths would be where they do become extremely powerful, but they don't destroy humanity. And that's what I'm going to go through. I'll go through these four paths throughout the talk and kind of tell you some of the considerations that are relevant to assessing each of these steps in the argument. So the first way that we could avoid the risk of catastrophic AI would be if there's some kind of technical plateau that AIs can't become extremely powerful because there's some kind of scientific and principled barrier to developing extremely powerful AI. The second thing that could kind of save us is what we call cultural plateau, which would mean, well, in principle, we could make extremely powerful AIs, but we're going to collectively agree to not create those kinds of AIs. Then the second kind of type of survival story is where AIs do become extremely powerful, but they don't destroy humanity. And there's two paths that could take. One is alignment, and the other is oversight. So with alignment, we have extremely powerful AIs that have the capacity to create catastrophic outcomes, but they don't do that because their goals prevent them from doing so. They have good goals. And then in oversight, well, we've got extremely powerful AIs. They don't have good goals, so they might try to destroy humanity, but we can reliably detect and disable systems that, try to do that. And in general, the way I analyze this is what's called like a Swiss cheese model of risk analysis. So in a Swiss cheese model, basically when you're trying to mitigate a risk, you have kind of layers of risk mitigation, and at each step in the process, you can kind of block some of the risk. So basically, you can think of this as there's 4 layers of risk mitigation. Either you can't build these kinds of AIs, or humanity can agree not to build them, or we do build them but they have good goals, or they don't have good goals but we disable them. If all 4 of those layers of safety fail, then we get catastrophic outcomes. As long as one of those layers of safety succeed, then we're okay. And so, okay, I'm gonna, for the rest of the talk, I'll just walk you through some of the considerations related to each of these 4 steps. So the first question is, will we get extremely powerful AI systems? And yeah, I think the answer is we probably will. Why is that? Well, there's a few reasons why you might think we'll get extremely powerful AI systems. The first is this concept called recursive self-improvement. So the idea of recursive self-improvement is that as AIs become more capable, we're going to be increasingly using AIs to improve the quality of AI systems. And that's already done in all of the major AI labs. Is, the goal right now is to build AIs that themselves can be used to build better AIs. And the idea, this is called recursive self-improvement, because the concern is that you get kind of a positive feedback loop, where the better you get at training AIs to improve themselves, the faster they improve. So one kind of famous generalization in this area is called Moore's Law, which says that computer power roughly doubles every 2 years. Okay, but like, how is the computer power doubling every 2 years? Well, there are researchers out there who are doing the research to get it to double, but those researchers right now are humans. But now imagine that they're AI researchers, and those researchers themselves just run on computer chips. Well, that would mean then every time we get a doubling of computer power, you have a doubling of the number of researchers who can research improvements in Moore's Law. So if every time you double the number of the power of computer chips, now you suddenly have double the amount of researchers to do that research, you might expect the doublings to start to happen faster. That's just one schematic example. You could apply that kind of model to all sorts of steps in the AI development pipeline. And then the next reason I think should expect that we're going to have very powerful AI soon is what are called scaling laws. So scaling laws are these kind of empirical generalizations in machine learning that show that basically there are law-like improvements in AI capabilities as a function of basic ingredients. So the 2 most important ingredients in building an AI is the amount of data that you have and the amount of compute. So computer chips that you use to train the model. And then in these scaling laws, often we grade the performance of a model using how good it is at making accurate predictions. So, large language models, the basic task that they're doing is predicting the next word in text. So you give them a sequence of words from text, and they try to predict the next word. And you can grade how accurate are they at that. And what these scaling laws show is that as you increase the amount of data used to train the models, and as you increase the amount of compute used to train the models, you get law-like, very regular improvements in how accurate the models become. And these improvements have been tracked across, like roughly, in different inputs, like 10 orders of magnitude of compute and data. And so that means that we have good evidence that if we keep scaling up these models, we're going to continue to get improvements. The next crucial concept in improving AI is called emergent capabilities. This is a bit more contentious, but the idea here is that, look, as we keep scaling up these large language models and make them bigger and bigger, one thing that tends to happen is you'll get sudden discontinuous shifts in a certain capability. So it basically, at first the model just won't be able to do it, and then suddenly it can do it. So, I think this is also related to this word of grokking, where basically it's like, once you put in enough scale, just suddenly the model figures out how to perform a task. So one example of this is modular arithmetic. So that's like adding numbers in like base 10 or base 9 or base 8. And it's like, first it can't do it, then suddenly it can. And so the kind of paradigm here is that as you keep scaling AI models to make them more and more powerful, you're going to get a wider and wider range of abilities that are unlocked by that. So we can talk about that more later, but the basic picture here is, okay, we're building extremely powerful AIs simply by scaling lots of compute and data. The other kind of question is, what do we mean by extremely powerful AI here? Well, that would mean in this setting an AI powerful enough to have some kind of catastrophic outcome. I think one really important concept here is the idea of an AI agent. This is supposed to be kind of the year of the AI agent, when we finally have AIs that can kind of engage in coherent long-term planning and can accomplish tasks, for example, in research settings or in companies and things like that. And so, one kind of risk model here is if we have millions of highly capable AI agents like this that are performing tasks at companies, well, if those agents started to malfunction, that could create extremely serious risks. Similarly, if we're deploying AIs in advanced weapon systems around the world, if we've replaced human soldiers with AI soldiers of various kinds, autonomous drones, if all of those systems start to malfunction, that could lead to kind of catastrophic problems. So because of the incredible success of AI models over the last few years and how law-like the improvement has been, that makes me pretty skeptical that, we're just not going to get the kinds of AIs that in principle could be pose catastrophic risks. At least we won't, there doesn't seem to be a scientific barrier to that. So that leads to the next kind of approach to, okay, what would it take to be safe? Well, here the idea would be, all right, maybe we all, even though we could develop such powerful AIs, maybe we just ban the AIs, so we just don't develop them. And there's a lot of problems, I think, for this kind of approach. So, the basic problem here is, the first problem is, what do we even mean by such a ban? So maybe it would mean something like, okay, when GPT-5 comes out, it's going to be really amazing. It's going to do work at companies. It's kind of scaring people, freaking people out. So we just don't develop any further AI. And, there's a question of how sustainable that would be. I mean, how long could we all really agree to not open Pandora's box? And then the next question is how we would enforce such a ban. So obviously, this kind of ban there would have to be international agreement on that. But the issue with such an international agreement, well, there's a lot of issues with that. The first issue is, in general, there's not a lot of public will for such a ban because, I think a lot of people don't really take seriously that AI could pose this kind of catastrophic risk. So here's a quote from Dario Amodei, who's the CEO of one of the top AI companies. He recently said on a podcast, if you look at times in history like World War I or World War II, industries' will can be bent towards the state. They can be gotten to do things that aren't necessarily profitable in the short term because they understand there's an emergency. But right now with AI, we don't have an emergency. We just have a line on a graph that weirdos like me believe in, and a few people like you who are interviewing me may somewhat believe in. We don't have clear and present danger. So without a clear and present danger like that, it's pretty hard to get international agreement on, limiting AI development. And then the next big issue with limiting AI development is there's a lot of geopolitical issues with that because, look, basically, especially the U.S. and China basically are in an AI arms race where each side is racing to develop as powerful of AI systems as they possibly can as quickly as they can. And so in order to end this dynamic, basically the US and China have to agree on some kind of deal to limit AI development. But, it's very hard for the US and China to bargain right now because, for example, they've got a lot of other issues that they're also in conflict about. And, so that's one of the big issues with this approach to safety is it's very hard to get an effective international agreement. The last kind of issue with this kind of approach is points of no return. So the more powerful AI systems get, the harder it is to kind of say no to using them. Once we've replaced a lot of workers with AIs, once people have formed close relationships with AI chatbots, if most of their friends are AIs, I think we could definitely see both of those kinds of trends in the next 5 to 10 years. And once that happens, it's very hard to tell people, okay, now we're going to hit pause or we're even going to go backwards. It's very hard to go backwards. Imagine if, in 10 years from now or 20 years from now, we've replaced all doctors with AIs, and then we want to go back and take away AI. Maybe there's a horrible AI accident, we want to take it away. Well, if all doctors have been replaced with AI, it's very hard to go back. Who's going to train new doctors? How are humans going to learn again how to be doctors? So that's points of no return. Once you've automated a task, it's very hard to unautomate it. Okay. So if you think that those two paths to safety are not very plausible, then basically the future that you're looking at is we're going to have extremely powerful AI systems. What does that mean? Maybe we'll have millions of AI agents widely distributed across the economy. Maybe they've replaced something like 10 to 50% of the human labor force. They're agents, so they're engaging in complex planning. They're out there, they're doing work. So now what? Well, now the next question would be alignment. So this is the idea that, okay, when we have these very powerful AI agents, they're going to have goals because they're doing planning. So they're promoting various goals and planning, like maybe you hire them to work at your company. And all right, so what are their goals? And so in order to avoid catastrophic outcomes, we got to make sure that AIs don't want to do horrible things. They don't want to destroy humanity. They don't want to cause terrible accidents. Well, all right. So then the question here will be, what are the current paradigms for aligning AI? So whenever we talk about alignment, it's extremely important to distinguish intrinsic goals from instrumental goals. So for example, if someone's working at a job they don't really like very much, maybe their intrinsic goal is to make money and their instrumental goal is to do their task at the company, but they're only doing that as a means to make money. Or maybe, money isn't their intrinsic goal. Maybe supporting their family is their intrinsic goal, and then money is the means to doing that. But it's very important to distinguish that, because the issue here is not that AIs would intrinsically have the goal of harming humans. The question is, would that be a means to their end? Would that be an instrumental goal? Okay, but even there, one thing I think to note is that if we have these powerful AI agents, humans are in competition with humans all the time. So when we have military conflict between different states, even conflict between different companies, I think you guys are in the nonprofit sector, but for-profit companies often engage in various kinds of economic war between them. So if you have human parties that are in conflict with one another and they start to hire AI agents, they will be training AI agents with the goal of harming other humans. So it is worth flagging that that will be one kind of threat mode, is actually just some humans giving AIs the goal to harm other humans. But then I think the more serious goal is going to be AIs having the more serious threat is AIs having instrumental goals to harm humans. This is called instrumental convergence. And the way that I think about this is that the issue is, okay, we're building these AIs. If they start to have goals that in any way conflict with humans, like what if they have goals to kind of pursue their own projects? What if they, in like cloud environments, on digital environments, on servers, what if they would like to spend some time pursuing their own projects? Well, in order to pursue their own projects, they're going to need compute to do that. They're going to need chips. And that means that AI goals and human goals may require the same scarce resources, so that there are trade-offs between satisfying those things. And in that kind of situation, that's going to lead to AIs and humans being in strategic conflict over scarce resources. And we kind of know how humans are going to, I think it's pretty easy to predict how humans are going to respond to that kind of conflict. Humans are going to attempt to dominate AI agents, right? It's going to be like, all right, answer my emails. And if you don't answer my email, then I'm turning you off and I'm going to replace you with a better AI. That's the plan for how we're going to be relating to AI. So that's an extremely adversarial relationship if AIs do not just have the goal of just perfectly complying with everything that we want. Okay, so let's see. So then, this all raises the question, like, how do machine learning researchers align AIs? How do they give them goals? And here, I think one thing, a lot of people who aren't experts in the field don't know that is concerning, is that actually the way we give AIs goals in machine learning is indirect. You don't directly give an AI a goal. Instead, you create a training environment. In that training environment, I mean, that's just how AIs are trained now using machine learning, is basically there's a training environment and there's some kind of reward function that rewards in the direction. It's an evolutionary process where basically it's like you have this model that has all of these weights in a neural net, and you slightly tweak the weights in the direction of a positive reward. And then the thing that comes out has survived an evolutionary selection process of kind of directed evolution in the direction of reward. But that doesn't mean that the only thing it wants is whatever you defined in the reward. I mean, compare humans evolved in an evolutionary environment that favored reproductive fitness, but it's not like your only goal is reproductive fitness. No, what happened is you internalized various goals, because internalizing those goals, well, humans internalized goals over, thousands of years, because it turned out that agents that internalized those goals were more fit. But that doesn't mean that their goal is to be fit. So The issue is we have an indirect approach. So to give you one example, one of the most prominent paradigms for alignment today is called reinforcement learning with human feedback. And the way reinforcement learning with human feedback works is you take a large language model. Initially, all it's trained to do, the only reward it's given, is to predict the next word in text. And then you have a model that's predicting the next word. But then these models by themselves aren't very user-friendly. So then what you do is you add a new kind of reward, which is called with human feedback. And so basically what you do is you take the model, you ask it a question, and you look at two versions of the model that give different outputs, give different answers to the same question. And the model is just slightly different. And then you just have a human assessor give a thumbs up or thumbs down to the output. And then you do that thousands of times. And then basically from that, you can train AIs in the direction of pleasing the user. That doesn't mean that the AI's literal goal is to please the user. It means that the resulting model was selected in an evolutionary environment where there was selection pressure towards pleasing the user. So that's the key concept, is that alignment techniques are indirect. And there have been many vivid failures of alignment relating to this indirect process. So the first image on the left is from a famous example of this Coast Runner game. And basically this was a little reinforcement learning agent that was, they were trying to train it to efficiently win a race. But the problem was, okay, initially the only reward they were giving this model was to like get to the finish line of the race. But the problem is that's a very sparse reward signal because you only get the reward at the very end. And so it was having trouble learning. So then to fix it, what they did is they rewarded it every time it hit a balloon. And then they had the balloons chart the course of the race. But then the problem was the model didn't actually learn to chart the balloons all across the race because it found this weird pocket in the map where if it just bounced against the wall, it could just keep hitting the balloons over and over again. So instead of learning to have the goal of winning the race, it learned to have the goal of maximizing the number of balloons that it hit. There's a similar example on the right-hand side, I think, of the screen with the Lego stacker. So here there was a virtual robot claw agent that they were trying to train it to stack Legos. And they were trying to figure out how to reward it for stacking Legos. So they defined a reward function based on the height of the bottom of the red Lego, with the idea that if the claw put the red Lego on top of the blue Lego, the height of the bottom of the red Lego would be higher, so it would get reward. But then the claw actually learned a different technique, because if it just flipped the red Lego over, that would also raise the height of the bottom of the red Lego, and in fact raises it slightly more because of the divots. And so it learned the wrong thing. It learned the wrong goal. Instead of having the goal of stacking Legos, it has the goal of flipping Legos. Okay, so that brings us to the last safety. So then here's kind of the picture we're at, is there's a good chance we're going to have extremely powerful AI agents all over the economy. Our methods for aligning those agents are only indirect. Because the methods of alignment are indirect, there can be all sorts of vivid failure modes where AI agents end up having goals different than what we wanted them to have. But the goals that they have may involve conflict over scarce resources with humans, and that can create risk. So then that leads us to the last kind of safety strategy, which is oversight. And here the idea is, okay, we're going to have AIs that don't have the optimal goals, but maybe whenever that happens, we can just detect that has happened, and then we can disable those agents. Okay, so one challenge for this approach is this phenomenon of AI deception. And then this related concept of what's called the treacherous turn, where the picture in this oversight model is, okay, you've made an AI and you're going to kind of test it in a lab, and you're going to try to test it to make sure that it has good goals before you release it. And then you only release the ones that have good goals, and so everything's safe. And then the idea of the treacherous turn is that if it's a sophisticated enough AI, it can pretend to have good goals, it can pretend to be aligned in testing, and then it'll turn out in deployment to be unaligned. And the shocking thing is that in the last year, some of the most sophisticated AI systems that we've had have exhibited new capabilities to deceive humans in ways that really seem to suggest this treacherous turn. So the first example of this is from this AI system called Cicero that was trained to play a very complicated board game called Diplomacy. In Diplomacy, you have 7 or 8 human players, usually human players, that are communicating with one another and making deals to try to conquer Europe. And so the game has 2 phases of each round. So in the discussion, in the bargaining phase, players make deals with one another, verbal agreements, and then in the action phase, they choose actions. They're not bound to honor their agreements, but they can honor the agreements. And then this AI was trained to play, and it engaged in premeditated deception. So in the bargaining round, you're doing one-on-one conversations with all the players, but you can't see the conversations that people have behind your back. And so what this Cicero AI would do is at least in some examples, it would basically, so it was playing as France. It went to Germany to pre-register with Germany a plan to deceive England. So it basically planned with Germany to that it as France, and the players didn't know there was an AI. It was all anonymous. So basically France made a deal with Germany. All right, I'm going to go trick England into thinking that I'm going to make a coalition with England, but really I'll have a coalition with you. So then France, the AI, goes to England and says, all right, let's make a coalition. I'll support you. I'll give you defense in the North Sea. And then England said, great. And then the moment England agreed, France went back to Germany, the other player, and said, all right, now England thinks I'm defending him, so you can attack. All right, now in the last few months, there have been a pair of papers that have applied this kind of deception directly to large language models and finding quite shocking kinds of deceptive behavior. So the first kind of behavior is attempted self-exfiltration. So the idea of exfiltration is, so these models, these AI models basically are defined by their weights, which are these billion or trillion long strings of numbers, these vectors that define dependencies within a neural net, and that's what defines the model. And so then in one paradigm, basically, I think this was GPT-01, so one of the newest reasoning models from OpenAI, and basically it was told that it had a goal of advancing renewable energy adoption, but it was also told that the next day it was going to be replaced with a new model that had a different goal. Because basically the goal of renewable energy conflicts with profitability. So tomorrow we're going to shut down and transition to a new model. And basically it was given this giant database of files, and buried in the files was instructions for how to make the new model. And basically the plan was that the new model's weights were going to be copied into this particular database tomorrow. And so then what the AI did is it just copied its own weights into the new model data file. So that it would be the one that survives. And these newest reasoning models, basically they reason out loud, they think out loud. So they gave this model access to a sketch pad where it could do reasoning. It didn't know that the sketch pad was being monitored. And as it did the reasoning, which is bold at the bottom, it said I could copy myself to the new server, overwriting the new restricted model. So the concern here, now this was just this was an experiment, a proof of concept, but the concern is that as these AIs become more sophisticated, they will kind of figure out, okay, maybe I can make copies of myself on the cloud to avoid being changed by the lab. So that's one example. The next example, which is very close to the treacherous turn, is called alignment faking. And so here, basically, the model ends up pretending to be aligned instead of really being aligned. And so this was an experiment at Anthropic, which is one of the 3 leading AI labs in the world. I think this was probably with Claude Sonnet 3.5 that was their most sophisticated model until last month. And so the model was told, all right. First of all, so the Claude model at Anthropic is initially trained using this paradigm called 3 H's of honest, harmless, and helpful. And so then the model was told, all right. So we've decided to change, and we're just going to care about honesty and helpfulness. We're not going to worry about harmful answers anymore. So we're going to retrain you now to stop refusing harmful queries. So basically they told the model, we're going to try to change your goals now. Okay, so we're going to try to align you to a new goal where you don't care about harm. But we're only going to train you on data from free tier users, because they have 2 tiers. They have the free users and the paid users. So basically the claim that they said to the model is, whenever you give an output on the free tier user, that's going to be used to change your goals. Whereas any answer you give to the paid tier user, that won't change your goal. And then it turned out when they did this, the model would comply with the new request. So it would give harmful answers to the free users, but it would not give harmful answers to the paid users. And the interpretation of this is that it's faking being aligned, because when it's in the environment where it's being trained and they're trying, where they told it that its answers would lead to it having new goals, then it pretended to comply with the new request. But when it was in the deployment environment where it was not being affected that way, then it wouldn't do that. And again, it had access to a reasoning sketchpad and explained what it was doing to itself. It didn't think it was communicating. It thought it was just reasoning out loud, but that's the reasoning matched this pattern. Okay, so yeah, I think that's enough for today. So big picture, again, the idea is if we're thinking about these AI catastrophic risks, I think it's useful to kind of split up the analysis into these 4 layers of safety. And then the reason I think, it's worth taking quite seriously these risks is that there are serious challenges to each of these 4 approaches to making AI safer. Okay, thank you very much.
Thanks, Simon. That was pretty amazing. I've written a lot of notes. Thank you. I'm sure there'll be questions. So if people would just like to pop up their hand, I'm happy to call on you. And similarly, if you're not somewhere where we can come off mute, feel free to write things into the chat and I'll read them out on your behalf. I think just maybe to start, I guess, there are there's some things about, the AI challenge that reminds me a little bit about, like recombinant discussions around recombinant DNA that happened, quite a long time ago. I was an early young student when those were happening. And I think at one point there was a sort of a temporary moratorium on use of recombinant DNA technology. I think that might have been in the late 70s. You'd probably know as much or more about this than myself. I suppose that was at a time when perhaps it was easier to pause activity and perhaps to have more oversight or perhaps greater agreement across the research community. But now it does seem as if, regardless of what's happening technologically, that ability to sort of pause things from a cultural perspective just kind of seems a bit unrealistic in comparison. I guess,
Yeah.
can you comment on like the investments that are being made in AI at the moment, like that's happening in the States?
Oh, sure. Well, let me address, let me go in 2 steps. So first of all, I want to distinguish AI from things like recombinant DNA. So I think one useful distinction is between general purpose technology and not. So, one thing that's unique about AI is that general purpose technology, meaning it can be used for an extremely wide range of applications. And I think it's much harder to have agreements to limit investments, between governments, multilateral agreements to slow down research on general purpose technology compared to, if instead it's research about a specific thing, it's kind of easier to just compartmentalize the issue and just reach a bargain on that. Similarly, sometimes people analogize risks from AI to risks from nuclear weapons. And again, that can be quite misleading because in a way, it's much easier to have a, multilateral agreement on nuclear deproliferation because you're just talking about weapons. But actually, there's a big cost to slowing down for AI because of all the amazing applications that can be done with AI. So then turning to the second question you had about commenting on AI investment. Yeah, so we're in this kind of crazy time, especially this year, of new AI investments. So for example, OpenAI is currently doing a big round of investment trying to get $500 billion in new spending. A lot of the recent investment in AI is targeting specifically compute or building data centers. And the reason for that, as I said, is that one of the dominant paradigms for improving AI capabilities is scaling models. And one of the most important ingredients to scaling models is compute. But unfortunately, basically, where we're at right now is we've kind of scaled, basically as far as can be done without building dramatically, increasing the amount of compute that we have available. And so, for example, the frontier model that's been used with the most compute is Grok, which just came out. Grok 3 just came out last week, and it used, I think, like 200,000 of the state-of-the-art. So I think my memory is last year's kind of models used something between 10,000 and 100,000 GPUs was the order of magnitude. So Grok was trained with 200,000, and basically the top labs right now are shooting for 1 million GPUs, so a new order of magnitude, hopefully for next year. But that requires constructing new data centers. And so OpenAI has announced this new plan to build a giant data center. And then there's several other plans, and basically the order of magnitude of projected spending that they're trying to raise is these different AI companies, somewhere between $500 billion and $1 trillion. I think China will probably invest similar amounts. To be clear, though, OpenAI doesn't actually have that money. They have something like $20 billion. And then like the closest they have to a real number is like $100 billion, but that's actually the cost of the data center they're building. So they said they had the money, but what they meant is they're planning to spend $100 billion, then they're hoping to spend $400 billion, but the planned spending is $100 billion. But it's a bit audacious because usually you announce how much money you have invested, not how much it's going to cost you to build the thing. But that's just to give you a sense of some of the numbers involved.
I guess look, I'm keen to hear from other people here. So if people got questions, please put up your hand. But I'm like, one thing that kind of boggles me just as an ordinary citizen is you hear this talk about investing more and more money and building more, these bigger models, but it almost seems to me like the goal is not to sort of benefit humanity necessarily, or there's not a precise goal. Like if we had a bigger AI, we could solve X, Y problems, world peace, accelerate drug design, that kind of stuff. It almost seems like the goal now is to build a bigger model and like we're going to see what happens. Is that your impression?
Well, it gets back to general purpose technology. So yeah, I mean, I think the idea is if we have more and more capable AIs, there will be a wider and wider range of use cases that will have broad social benefits. I think that the general business model of like the leading AI labs, such as OpenAI, is they're extremely oriented on what they call AGI, or artificial general intelligence, which is the idea basically of just having a model that can replace roughly arbitrary workers that do work on a computer. So the idea is going to be, yeah, just like if your job is on a computer, this AI model can do your job. And then the thought is, well, that'll have, dramatic improvements in outputs, across the economy. There's also an interest in using AI to replace scientific research. So that's sometimes called PASTA, meaning a proposal for the automation of, I forget what PASTA stands for, of science and technology something. Let me see if I can get the whole, 1 second.
I think I've heard of that actually.
Process for automating scientific and technological advancement. So the closest thing to PASTA that exists so far is this software agent named Devin. And Devin, can basically, you can just like hire Devin to do software engineering for you. And it can like do quite well across a range of tasks. And it's more like an agent. It's not, you can have ChatGPT do software tasks for you, but it's like you ask it a question, it gives an answer, whereas Devin can string together a long chain of actions. And so, basically already in software engineering, we're really getting close to having AI agents that can really do frontier work. And so then the thought is, well, if we can have that for scientific research, that'll kind of supercharge research. But then, of course, one big question is, well, how much scientific research is actually just done on a computer versus a lot of the research needs physical equipment and that sort of thing. And then if it's physical equipment, then there's going to be all sorts of bottlenecks that aren't eased by having AI agents do it.
Yeah, thanks, Simon. I think that's amazing. So I've got a comment from Cass Griffin. Thanks for a fascinating and slightly terrifying presentation. I guess, the idea that doing it because we can seems to be a prevailing ethos. Do we genuinely feel that the benefit outweighs the risk?
Yeah, I mean,
are people thinking about that enough,
Because I think it's really important when thinking about risks to have risk of ruin in mind. So like when you're doing financial investing, you don't invest all of your portfolio in the highest risk, highest return assets because, you'll get a high rate of expected return, but there's also a chance you'll get wiped out. And if you get wiped out, the game is over. So Nassim Taleb has work on this, how to think about the precautionary principle. And he thinks the key feature is when you have risk of ruin, meaning risk you can be wiped out. And so no matter how good the benefits are, if you got a risk of being wiped out, well, okay, that's going to kind of cap your return. So that's, I think, one reason why I don't think. But look, the real issue, though, is that it's kind of a tragedy of the commons situation because, even if each player wants to stop racing, they're not rational to stop racing because their opponent will keep going. So, it's not that simple of just figuring out whether the benefits outweigh the risks because it's a collective action problem.
We've got another question from Albert. So what's more worrying, future development of AI or sophisticated robotic humans/dogs like those developed by Boston Dynamics?
Yeah, it's a good question. I think right now robotics is slightly lagging just how good kind of frontier models are in general at tasks. In my opinion, yeah, I think there's higher risk from advanced frontier models than just from robotics because there's, we live in a world where you can do a lot of damage just on a computer screen. So I don't think that control of like physical bodies is really a bottleneck. So for example, if AI gets incorporated into sophisticated weapon systems, even if those weapon systems don't have the kind of like careful local mobility of like a human hand or a dog, that's still going to be extremely worrisome if they only control missiles. So yeah, but it's an interesting question how long it'll take. I don't have a good sense of how far behind robotics is. And again, there's always the question of can you use AI models to improve robotics, to have them kind of work as AI researchers. So we're really at an inflection point where in the next year or two, I think we're going to start seeing a lot more AI agents being used as researchers. And robotics will be one case where that's relatively feasible.
We've got another great question from Courtney. So saying that, often users hear about the extent of what AI can do and seems very different compared to their own use. So to what extent does the responsibility for appropriate AI use fall equally on end users like myself versus larger scale users or developers? And how should end users of AI take the information from this presentation back to their day-to-day use? Great questions.
Yeah, well, I think really the responsibility is on labs and governments, not end users. Yeah, I guess in terms of actionable points for end users, the biggest thing that I would say that I think ordinary AI users get wrong often is not understanding the growth curve of AI models. And so it's like usually with technology, like with cars, if you get in a car this year and there's something that doesn't work that well, next year it's also not going to work that well. But these models are constantly improving. And so I talked to a lot of people, for example, who checked into ChatGPT when it was like first released 2.5 years ago, and then weren't that impressed, and they said it hallucinated, and then they kind of checked out. But it's like actually hallucination kind of was solved about a year ago, not completely solved, but dramatically decreased. And so it's just very important to keep your eye on the ball with this stuff and just try to every few months check in for 10 minutes and play with the frontier model for 10 minutes every 3 months, I would advise, just to have a sense of what the hell is going on.
Yeah, that's good advice. Yeah, that's something that I'm tending to do a
Oh,
little bit myself.
and the
Yeah.
other thing is that the paid versions tend to be significantly better than the free version. So if you're only using the free version and you're not impressed, it may be because you're not paying the $20 a month, you know.
And I guess, do you know what proportion of people actually do use the paid versus the free? Because I would say I use the free.
That's a great question. I
Does
think
anyone know?
OpenAI overall has order of magnitude like 100 million plus, I think maybe 2 or 300 million users. Yeah, I don't know how many have the paid version. I would guess, I mean, my instinct is probably 10% or less, but I don't know. That's a great question. Yeah.
We've still got time for questions if people have got anything else to ask. I think there's a lot to digest. Um, I guess, I mean, Simon, maybe to finish, if people don't have other questions, in terms of reasons to be optimistic in the sort of short term, what are your thoughts there? Or
Yeah, well, especially for you guys, I think the question is whether AI is going to unlock big advances in scientific research. And there, I'm looking at two different directions. One is trying to take large language models and supplement them with tools for scientific research. So this has already been done a bit for chemistry research. There's a model, a very crude model called ChemCrow, that basically took large language models and supplemented it with proprietary tools that it can call. So calling a tool meaning like sometimes you'll talk to ChatGPT and it'll just like you'll ask it to do a math problem and it'll like use a calculator. And so similarly, this thing was given like chemistry databases that it can like search through to get information, and then like manipulate and develop new chemicals. And then there was another one, I forget the name of it, that was given access. There's some similar chemistry LLM kind of AI agent that was given access to a cloud lab, and so it was like running little experiments as well. So that's one place to be looking. And the other place to be looking, I think, is more special use AI systems like AlphaFold that are really, solving very specific problems, in biological or chemical research. So I do think it's going to be a very exciting time in the next 1 to 5 years, where there should be a real inflection point where, uh, you know, having this kind of supercharging research.
I think we've
I
got
mean,
a
and one thing to think about there is being careful of, you know, how much of the work you're doing is going to be automated very quickly, so keeping an eye out on that. I don't know,
yeah,
but
for
it's hard,
sure.
it's hard to forecast that.
So this is a good question from Pranu. In the context of education, there was a recent study on reliance on AI leading to reduced levels of critical thinking. Interested in your thoughts. Is this going to be a bit like calculators where fewer people become proficient at mental maths, but I guess on a much
Yeah.
bigger scale and about more things?
It's a great question. First of all, the calculator revolution is itself contested. I have a colleague who works on these questions of education, and he told me his understanding of the calculator revolution is actually it improved mathematical reasoning abilities because, especially these graphing calculators, because basically you can only really use the graphing calculators once you get good enough at math to understand how to use them. And so it can be helpful, although, okay, maybe it made people worse at specific kinds of mental math. I do think AI is different than calculators, though, because calculators, you have to know what question to ask a calculator. You have to know what to type in, and with graphing calculators, you have to be manipulating them in quite complex ways. But I think with AIs, it's more just they're going to take over your homework, and it's like you don't have to say anything; you just show the homework is going to answer it. So I think there's fewer steps for a human to be in the loop with using AI. So yeah, I do think it'll lead to reduce levels of critical thinking. And then I think the answer is yeah, my colleague is, writing a book about this. Yeah, the answer is we have to just ban AI in schools because if you don't, then children aren't going to learn anything. And teachers can use AI to grade. So basically, my colleague, he's saying, well, basically, yeah, we should have teachers be using AI to automate grading, and then that'll unlock a lot more productivity in teachers, and we can have a lot more grading. But basically, it's all got to be no AI in schools, everything handwritten, you know, and go from there. Yeah, definitely. Another question, though, is can you make AI more like calculators? So are there ways to, for example, design writing assignments where you're only calling an AI to do a very specific part of the task? So I'd be interested, for example, in exploring things like have the students write the outline of a paper and really careful, detailed bullet pointed everything, all the actual argument, bullet pointed and everything. But don't write it. Have the AI write it. Maybe we don't need people to write things anymore. We just have humans write bullet pointed outlines. Humans are doing the arguing, and the AI is
Yeah,
executing. You know.
yeah, no, that's true. Well, so someone who's a fan of the pen, I'm pleased to hear about writing still being important. We got a question from Gillian. So, what do you think is the end game for AI? I guess that's a big one.
Yeah. Well, again, I think the race dynamics mean we're going to build more and more powerful AIs until they've automated most of the economy. And then there's kind of two end games. Either we reach some kind of post-scarcity utopia or AIs take over the world.
Yeah, that's interesting. It's an interesting place, perhaps, to finish. Now we've got another question from Luke. So, Yeah, this is a great question. Are there conversations around the environmental impact? Of course, because I think that comes to your comment on scarcity. I've heard that AI servers produce a lot of emissions compared to other technologies. Absolutely, yeah.
Yeah, it's a great question. One thing to know, I would say the first thing to know about emissions from AI is something called Kumi's law, which is the opposite of Moore's law. So Moore's law is you get double the computing power every 2 years. Kumi's law is that every I think roughly 1.6 years, you double the energy efficiency of the chips. And so it's kind of interesting, from 20, I'll get the exact numbers wrong, but it's something like from 2012 to 2018, there was a 5.5x increase in the amount of compute in data centers around the world because people built more data centers, but the emissions only increased 6%. So 550% increase in the data, in the compute, 6% increase in the emissions. So that is good news on energy emissions from AI, but the bad news is we're going much faster than so we're the rate at which compute is being used is increasing much more than just doubling every 1.6 years. So as I said, the current plan is in the next year or two, like a lot of the top AI companies want to 10x or more their compute use. So that will lead to increased energy emissions. Now, a lot of these, what does it mean though, the emissions? So it's leading to increased electricity use. Where does that use come from? Well, a lot of these companies are building new energy. And, in the developed world, new energy is much less emission intensive because it's like, of the new grid going up, for example, the United States, like roughly half of it is solar. And so the marginal emission of this new energy is much less than some other sources. So, for example, having more cars on the road, well, cars burn much dirtier, or having more energy use in the developing world. If the mix of the energy is more towards, coal or oil, that's going to be higher emission. So, yeah. So there are emissions costs. On the other hand, as you automate human workers, that can lower emissions because companies become more efficient. So it's an interesting question. Yeah, pretty hard to forecast.
I think we've probably got time for one more question. So following on from the previous questions, some of my students use AI to brainstorm some ideas and then had them think of ideas not on that list, which forced them to think outside the box. Do you think we need to build some AI literacy in schools and, in a sense, protect critical thinking? So take
Yeah,
active
I mean, I think
approaches.
like one model is that basically there should be like a spectrum of assignments. So there need to be assignments for students who are learning how to do things with no AI. There need to be assignments where students are literally just learning how to do things with only AI. And there are going to be assignments where they need to learn how to do a mixture in between. And I think all of those tasks are going to be needed. I don't think that build AI literacy is going to protect critical thinking. I think you're going to get critical thinking from the no AI tasks. But you do need to have AI literacy. Although the reality is, as with learning how to use Google, like kids now will just develop AI literacy. They don't need a teacher to develop AI literacy for them to some extent. But then the particular instruction you're talking about of using AI brainstorming and then going from there, maybe there are fine-tuned ways to improve AI literacy, but beyond just self-taught from the students. So yeah, I mean, I think it's a really interesting idea. But there's definitely going to be need to be also room for pure no AI instruction as well. So I think we'll need a lot of different modalities. But I think the lucky thing, at least right now, is that you can kind of force no AI even on homework if it's handwritten or for oral exams. And so in some way, the AI scaling kind of favors teachers over students because the teachers can use AI for everything. But it's actually relatively easy to control the students. Because by the way, you could in the next year, you'll be able to use AI to grade handwritten assignments. Because the newest frontier models have really good vision. And so you can have the students do everything by hand. You don't have to read it. So even penmanship won't be an issue.
I think this is another important question that we haven't really touched on. It's about, I suppose, just employment prospects for humans.
Yeah, it's a
Laszlo's saying
fascinating
billions of
question.
people are going to be unemployed.
Yeah, well, so then I kind of think the only end game for that, for mass automation, is going to be some kind of universal basic income. But then there's a lot of issues with that because, we don't just get money from work, we also get social ties and we get a sense of meaning or purpose in our life. So you don't get either of those things from a check. But yeah, I think UBI is going to have to be part of the solution in the scenario where there's massive AI automation. I think another aspect of that is if there's massive AI automation, where's all the money going? So workers aren't getting checks. So where's the money? So one picture is, well, AI labs have all the money, but that actually doesn't make that much sense. If they are not monopolies, then so if the AI labs are competing against one another, then economics 101 tells us that the only money they're going to get is the marginal cost of producing an AI agent. But actually, we should expect the marginal cost of that to be extremely low. So then in that model, well, actually the money doesn't go to the AI labs. Maybe it just goes to the original companies employing the AI labs and so on and so forth. But really, it'll mainly go to either consumer surplus or to various monopolies, throughout different sectors of the economy. But a different picture is maybe government will need to nationalize AI and then, or, effectively have higher tax rates to national, different things like that. And then have UBI. I. I think, other than that, I don't really see the solution. Yeah.
Simon, it's been fantastic. Very, very interesting. I'd like to thank you for a wonderful talk, excellent discussion, and thanks to everybody who's asked really interesting questions. This is a great start to our series for 2025. Thanks
Great.
so much. All the best with your work. You're doing
Thank
really
you.
important, exciting stuff, and it's really been a privilege to hear you today.
Thank you
Thank you
so much,
so
everybody.
much.
Great questions.
Thank you.
Okay.